Hi kids and welcome to the Magic Show. In this magic trick we are going to do some real programming with Hyperlambda. You see, when you're creating CRUD HTTP endpoints and sending emails and stuff like that, it arguably feels more like you're configuring your app than really actually programming it. And of course that is the intention with Hyperlambda and Magic. It is supposed to feel that way because arguably in many ways it simply is that way. Because Hyperlambda allows you to easily orchestrate together C# building blocks. However, in this video we're actually going to do some real programming, and in order to start, let's copy this bugger, which is basically just a file name, then go to your Magic dashboard, open up your files, open up your modules, your tutorials folder, and create a new file and paste in the name you probably already have on your clipboard. If you want to, you can filter to more easily find the file after you've created it, and then go down here and copy and paste this code and paste it into your endpoint. Click save, and then for simplicity reasons we're going to open an evaluator. We're going to open an endpoints menu item in a different browser tab. Then click show endpoints and filter according to branching, and then pass in a value for your condition. Of course it needs to be a boolean, either false or true. So if I invoke this endpoint with a condition equaling true, then it will return yep, it's true. If I pass in false, whoops, instead, then I get the value, nope, it's false. And if I pass in Thomas Hansen is cool, then hopefully I will get something completely else. And that's because the default conversion will kick in and see that, hey man, this is not the value of true, hence it has to be false. So there's an implicit conversion for the record from anything into a boolean value by the endpoint resolver. So anyway, what's happening here is actually that, first of all, we have an explicit arguments collection, implying if I do and foo equal bar, it will throw an exception because I threw in an argument that the endpoint doesn't legally allow the invoker to actually pass in. And then there's an if condition here, which is actually a Hyperlambda slot, and you can actually find the code for it in the magic.lambda project if you wish to. And actually, let's comment this thing to make it slightly more readable. These are the arguments the endpoint can handle. And then this is an if-else statement / Okay. So what's happening here is that this if slot requires two children, one children and two children. The first child can be anything. It can be a slot invocation, it can be whatever that returns a boolean value of some sort. The second node or argument to it must be exactly like this, .lambda, and this is actually the lambda block that is evaluated if the above thing evaluates to boolean true. Hence, when we pass in true here, this executes. When we pass in anything else, this executes. Pretty straightforward, I'd assume, for most people having done any type of software development previously. Now, here we go through and explain exactly. By the way, there's a link in the description of this YouTube video to this article from where you can find the code if you're interested in actually following it. Here's a description of roughly exactly more or less what I said so far. And then I illustrate a Boolean operators here. You see, one thing which is probably a little bit awkward about Hyperlambda for people who haven't seen it before. Just paste in some comments here, is that the and, I mean, Hyperlambda doesn't even contain the ID of keywords, right? So the and here is actually a slot, and you can actually find it. If you look through the magic.lambda project, you can find that and is actually a slot in itself, meaning it functions effectively the same as a function. And the and slot can require anything from 2 to 100 children nodes, and every single child node, which might for that record also be a slot invocation by itself, must return the value true in order for the AND as a whole to evaluate to true. And since the AND will end up looking like this, basically if everything inside of the AND lambda object happens to evaluate to true, then the if will execute and execute its lambda object, right? So this is basically the equivalent of, if you want to write it with traditional code, what this basically says, it says if condition 1 and condition 2, right? That's basically what this thing says. And then of course there's an else here. Of course there exists also OR, and you can nest Boolean logical operators like you see here. Basically this means OR, meaning any one of these two ANDs must evaluate to true. While again the AND only evaluates to true if both condition 1 and condition 2 is true here, while the second AND only evaluates to true if both condition 3 and condition 4 evaluates to true. To type this out with, you know, C# pseudocode, it would look roughly like this: 1 and condition 2, or condition 3 and condition 4. This is basically the equivalent of this thing, except this of course being some sort of like, you know, C#-ish type of programming language. And then of course we can test it, save, refresh here. So now we have multiple conditions, show our endpoints, branching, invoke it. Here is the condition 1, okay, let's put that one to true, let's put this one to true, whoops, let's put this one to false, let's put this one to false. Invoke, and condition 1 plus 2 or 3 plus 4 are true. If I change this to false, doesn't matter if I change this to true, then neither condition 1 plus 2 nor condition 3 plus 4 are true. That's because condition 1 is true, but condition 2 is false. Condition 3 is true, but condition 4 is false. If I set this one to true, I will get the opposite result. Now here is an example of looping. Let's create another HTTP endpoint, looping.c. Actually, we're not going to be using the endpoints for this particular example. So let me just copy this code. Then I open up the other browser tab here. Then I go to the evaluator. And here I'm going to paste in this particular piece of code. Then I'm going to click evaluate, at which point you can see that the dot result had a value of bar 1, bar 2, bar 3, which of course is the concatenation of the values of all of these nodes. If I add another node here saying foo4, and then maybe some spaces, and then foo5, then Thomas Hansen was here. Whoops. I did it in the wrong, I did it in the result code mirror instance, so I needed to copy and paste it and move it up here. If I then evaluate it, then you will see, ta-da, bar 1, bar 2, bar 3, space, Thomas Hansen was here. Because basically what's happening here is that this for each invocation will basically have an expression leading to .data's children nodes. So it will iterate and execute or evaluate its lambda object once for every single node that exists underneath here. Let's just delete these guys. Then it will set the result .result node's value here to the result of doing a strings.concat, basically concatenating two strings, starting out with .result's previous value. And then this bugger is a little bit different, because that node apparently doesn't exist, right? Because simply it is injected by the for each slot invocation. So every single time my for each actually executes its lambda object, I will have a data pointer whose name is .dp and who happens to contain the node I'm iterating over by reference. This is an iterator which is probably a little bit weird and intuitively in the beginning might be a little bit difficult to grasp. But basically what it says is that I have a data pointer, .dp, which is of type node which actually points to foo1 dot bar1 on the first iteration, foo2 bar2 on the second iteration, foo3 and bar3 on the second iteration, on the third iteration. And of course this is actually by reference, so I'm actually modifying the node itself, which I'm actually illustrating in my next example here. Because here you see I'm actually changing the value of the currently iterated node. So instead of just concatenating the value, the existing value into some resulting bugger here, actually I can delete this guy I guess, I'm actually modifying the value of the node as I'm iterating through them. And in fact, if I evaluate this, you will see that afterwards every single node beneath my .data node here have now updated their values and changed it to Thomas Hansen was here. Why? Because that was the source for my set value invocation here, which was pointing to my currently iterated data pointer by reference, right? So here I actually modified the nodes as I was iterating through them. Then further down it goes through how to change my tree. We have 7 basic slots to do that: set value, set name, add, insert before, insert after, remove nodes, and unwrap. All of these are fairly intuitively easy to understand. However, let's paste them into our evaluator here and let's have a look at their effect. So first I invoke set value pointing to .foo1, and my source for this invocation is Thomas was here. Okay, Thomas was here. Foo1 node's value changed to Thomas was here, from Hody to Thomas was here. Then I invoke set name, which basically does the exact same thing, except instead of setting the node's value, it sets its name. And of course, now the name of my node is Thomas was here too. Then I invoke add, passing in a destination being .foo3, being this bugger up here. And here are my sources, being 2 nodes, item 2, actually item 1, item 2, how they were. And now you can see my .foo3 node, all of a sudden, I'm now being given 2 new children. You see from line 3, 4, and 5 here, you see item 1 and item 2. If you go up to see how it looked like originally before it was executed, it didn't have any children. Here it has no children. Here it has 2 children. Why? Because I told it that I wanted to add children into the .foo3 node, and here are the children I wanted to add into it. Then we're creating slots, custom dynamic slots. Custom dynamic slot is kind of like a function. If I now click evaluate and I invoke slots.vocabulary, right, and remember this part, foo.bar, right, I created a slot, its name was foo.bar. If I now invoke slots.vocabulary, you will see, hooray, we now have a new function, right? So I actually dynamically created a function and its name is foobar, and of course this particular function happens to return, you know, true all the time, never anything else, period, end of debate, true. That's what it returns. And actually at this point we can actually see how the if sentence or the if slot can require slot invocations by itself, because here we are if signal foo.bar, which of course evaluates it true, then it will return dynamic slot return true. So hence at the bottom here now we should be able to find dynamic slot return true, and of course we do that here. And then I'm explaining unwrap. And by the way, dynamic slots can take arguments the same way your HTTP REST endpoints can do, by just simply adding nodes beneath your signal invocation to your dynamically created slots. Things are slightly more detailed, documented at the documentation. If you click the documentation button here, and then you go to the magic.lambda parts here, you will find much more detailed information about these particular slots. Unwrap is a little bit interesting, and that might be a little bit unintuitive for people who haven't seen it before. You see what we're doing here. First, we're creating a full bar slot, which, by the way, for the record, just overwrites our existing slot. So any slot can just like be overwritten without any problems whatsoever. This particular slot happens to invoke math.add, passing in get value of arg1 and get value of arg2 here. So what is arg1 and arg2? Well, actually, they're here. Right. However, our arg1 happens to be actually an expression leading to this bugger, implying the value of 5. And our arg2 happens to also be an expression leading to this bugger, having a value of 7. Obviously, this should result in 12, as you can see here further down. But what we then need to do, because if I don't unwrap this code and I execute this, something undefined is going to happen. Right? Why? Because it's actually trying to add two expressions together, and we can actually have a look at that by doing lambda to hyper log.info. Let's evaluate it again, and let's go to our logs and let's have a look at what actually occurred here. And as you can see here, whoops, that's the error exception. So you can see here, my arguments are actually expressions. And of course, at this point, since I use the root iterator here now to convert my lambda to Hyperlambda, before I invoke my log.info slot, passing in the string textual representation of this particular lambda block, then it actually would log the root object. So you can see here the root object here is slots.create, column footer bar. And the arguments here are expressions, and where are they pointing? They're pointing nowhere, right? So what I need to do here is that I actually need to unwrap these two arguments. What that basically implies is that it evaluates this expression and exchanges it with 5. Then it evaluates this expression and exchanges it with 7. At which point I no longer have expressions in my invocation to the foo.bar node, but rather actually static values. Sometimes the unwrap is necessary in order to do such things, because some points you must forward evaluate, quote unquote, your expressions, at which point, of course, obviously unwrap becomes important and your primary tool of choice. And I guess that's it. Basically, here you can see how to create C# extensions, slots, etc., etc. Yet again, there's a link in the description of this YouTube video to the article where I copied and pasted the code from, and you can also read the entirety of the tutorial if you want to, if you prefer to study it in slightly more slow iterations than what I went through it here in this video. Thank you for watching. Have a nice day.